All right. Oh, and you can see me there too? Huh, wonderful. Okay, so today we are going to be talking about dimensional analysis. Dimensional analysis is the #1 way we do math and chemistry. Now we're going to start out real easy, real simple to teach the concept, but it's going to get more complicated as we go. Today is all easy. Everything we do today should be relatively easy. What is going to happen is it's going to get harder as the week progresses. Today we're going to do basic problems, one-step and multi-step. Tomorrow we're going to do word problems, which involve you interpreting what the question is giving you. That's going to be a much bigger deal. On Thursday, we're going to deal with juggling multiple units at once, and that's basically how it ends. We're also going to add our good friend density back in on Thursday, because density is best done using this method than using the formula that we talked about earlier. So first off, dimensional analysis is a fancy way of saying unit conversion, but in a very specific way. Dimensional analysis involves us doing this kind of very step by step. The question that we are going to do now is, let's say I've got 29.6 inches, and I want to know how many centimeters that's going to be. All right? Now, in order to answer this question, I'm going to need an equality. I'm going to need to know how things are equal. Now, to that extent, you have a page that I have shared with you called the conversions page, which is going to look something like this. We are only going to really use this page for this chapter, and probably never again. But it allows us to know how these are connected so we can do math. So, okay, here we go. When doing dimensional analysis, the very first thing you do is you look at what the problem gives you. That is your known value. And you're going to take your known value and you're going to write it down with the unit, and you're immediately going to put a times and a line and take the unit and drag it down. This way, the unit will cancel. Because in the end, dimensional analysis is math guided by canceling units. So it is very important that we take our unit and we drag it down so that it will cancel. Now, earlier I had talked about equalities. Well, an equality is one thing equal to something else. In this case, we only need one equality, okay? And that equality that we need is 1 inch is equal to 2.54 centimeters. This is on your equalities page, which I will now be calling the conversion page. Is actually, I think, the first one on there. Oh, no, it isn't. The first one under length and distance. Now, this is telling me that 1 inch is equal to 2.54 centimeters. That means that these are equal but different, which is exactly what I want here. See, what I can do now is I can take my inches and I can change it to centimeters, because 1 inch is equal to 2.54 centimeters. Now, we can do this mathematically because math-wise, these things are equal, even if they are different. So it's basically like timesing and dividing by, 1 or the same thing. But we know that even though they are equal, they are not the same. Since I started an inch, which is what the problem gave me, and I'm ending with centimeter, which is what I want, then we're pretty much set, because what we are looking for is called the unknown, and that's where we want to stop. And as you can see, inches cancel, and I'm left with centimeters, which is exactly what I want. So my problem here is done. I'm going to end in centimeters. Now, we need to then do math here. Now, math is very simple when it comes to dimensional analysis because the general scheme is you multiply everything that's on the top and you divide everything that's on the bottom. So I'm going to take my trusty calculator. I'm going to type in the 29.6. Now, here I've got the 2.54 on the top. If you remember, I multiply things on the top. But if I look at the bottom, do you notice how it has a 1 there? If I multiply or divide anything by 1, does it matter? No, so you can ignore 1s. So don't bother typing that in. It's going to save you some time. Just ignore if it's just a 1. Now, if this said like 11.1, that's not 1. You would type that in even though it's made of 3 1s. Do you get what I'm saying? So if it's just 1, you can kind of ignore that because multiply or divide by 1 don't matter. So I do 29.6 times 2.54. I hit equals, and I get a whole bunch of numbers. I get 75.184. Class, did you get the same? Did any of you type it in? No, that's okay. Because I'd love some confirmation here just in case I typed it in wrong. So while you're checking, this is not our final answer. This is our raw answer. Getting the raw answer is always important, and we always want to do it, but it is not where we are going to end. Now, am I right, Miranda? Did I just see you nod? Do I have other confirmation as well? Okay, love. I like getting at least 2. Thank you. Fantastic. Thank you very much. Beautiful. Now, raw is good, but I want my final trusting answer. And to do this, we need to use significant digits. Now, fortunately, this is all about multiplying and dividing. So all we have to do is we go to the problem that we started with, the values that it gave us. Here, we've got 3 sigdigs. It doesn't matter what we grab from the conversions page. We're going to assume that they have infinite significance. Now, in reality, that's not true. But we're not in high-level engineering, so we don't need to worry about it. I am telling you as your teacher to ignore the conversion page as far as giving significance. You will get your significance from the problem. Whatever the problem tells you, especially the word problems, which we'll go over tomorrow, will give you how many significant digits you need to round to. I've got 3 that I started with, so this goes to 3. Sorry. I want to do this like I did earlier. So 1 digit, 2 digit, 3 digit. Then I look at the 4th digit. Does the 8 round up the 1? Yes, it does. 5 or above, give it a shove. So this means my final answer is going to be 75.2 centimeters. And I put a box around it to signify that I am done, and we are golden. That is how we do dimensional analysis in the one-step manner. Do you have any questions for me? Okay, now we are going to do a dimensional analysis that's not one step. So we are still going to keep a lot of what we're doing, and you should still see kind of the same ideas. But what we're going to do now is something that may not be done as easily as what I just did. So I got my known and my unknown. In this case, for this question, I am going to say, I want to know how many millimeters are in 0.12 miles. So I'm going to go from basically a little over 1/10 of a mile, and I want to know how many millimeters that is. This is definitely not going to be a one-step problem. As I look on my conversion page, there is nothing here that connects millimeters and miles in one step. So I'm going to need more. You will also find that there are multiple ways to do this, but the process is pretty much the same deal. We are going to start by writing our known value of 0.12 miles times line. Bring miles down. Right away, you want to get into this habit as fast as possible. You want to write times line and drag like this. You do not want to hesitate. You do not want to question yourself. You do it. The sooner that becomes automatic, the better this is for you because it sets up the whole problem. Okay? So I set that up. Now, I have a lot of places I can go. This measurement page has miles to feet and miles to kilometers. I can use either, and I will get an answer that works. We're going to start by going miles to feet. Something that may be a bit more comfortable for you. So the first equality that I need then, because I want to get miles to feet. If I look up, it says 1 mile is equal to 5,280 feet. Okay, but that's not to millimeters yet. I'm in feet. Now, if I look at this page here, there is something that says feet to centimeter. There's also feet to inch. I can go either way. But in this case, I'm going to go feet to inch because, again, I think some of you are probably more comfortable with that. When you look at that, you'll notice feet to inch is not on that page there. But you're here in America, you probably know there's 12 inches in a foot. Okay? You can do that. If you know an equality, as long as you put it in your work and they are truly equal, that's fine. I mean, I prefer you grab the ones from the page, but this one's in your brain, so that works. Now, I want to get to millimeters, so I need to go, okay, I've got inches. Well, I can do that thing I did earlier. 1 inch is equal to 2.54 centimeters. I can then say that there is 100 centimeters in 1 meter. And I can then say that there is 1 meter has 1,000 millimeters. So this here is not a one-step problem. It's a 1, 2, 3, 4, 5-step problem. I inadvertently gave you one bigger. All right, that's fine. Because the nice thing is, after you get past one step, it's the same way that you do each time. So here we go. I've got my 2 miles. That is my first one. That's right up here. Okay, so I have here 1 mile is 5,280 feet. Okay? I'm then going to continue by putting another times line. All right, now here, I'm going to take my feet and I'm going to bring it down. I also realize I've left me way too little room, but that's okay. I can solve that later. All right, now that I'm done from feet, I want to go feet to inch. 1 foot is 12 inches. For those of you who are following along on paper, feel free to work ahead of where I am. Especially because I did not leave myself enough room. So I'm going to scoot some things over. 1 inch is 2.54 centimeters. 100 centimeters is 1 meter. And 1 meter is 1,000 millimeters. By the way, this first thing was me planning out how I'm going to solve this. This was me analyzing my info. This is me setting it all up. Now, that said, I'm going to bring inches down. And I'm going to change inch to centimeter. 2.54 centimeter per inch. I keep going. I bring centimeter down. I change that to meters. Oops, sorry, I wanted to change colors there. For every 1 meter, there is 100 centimeters times line. I bring meter down and I change that to millimeter. Now, if I remember, millimeter is what I wanted to stop with. It was my unknown. So this is where I'm done. And there is 1,000 millimeters per meter. This here is my setup. And the setup is probably the most important part of what you're doing. So this is your work. This is what I want to see. I want to see it like this, a series of times lines with numbers, top and bottom. Again, this stuff is simple conversions. Later, it's going to get more complicated. Yes, Katie?
Would you be able to, like, not skip a step, but, like, make a step smaller by, say, 1 centimeter by 10 millimeters?
You could, and that would work. If you knew that or remember that, go for it. That's not what's on the measurement page, so I did it like this. But Katie was saying, could I do this? You could even sit there and go, hey, I've got 1 meter here, 1 meter here. I could just combine those and just stick the 1,000 millimeters here. You could do it like that too. So if you want to save a step here or there in a way that's you're comfortable, as long as your work matches, you're fine. And that's smart. So you can totally do that if you want, or you can do what Katie said, just going 10 to 1. That'll work as well. But understand, it is often better to just to use the tools you've got here until you get more comfortable. As you get more comfortable, then you can start playing around with it like I just did, but it's up to you. Now, so here we go. I take my calculator. Pro tip, you want to hit equals as little as possible. So for a problem like this, you should only hit the equals once. So here I'm going to type in my calculator, 0.12. I didn't need the 0, but I did it anyway. I times by 3,280. I can skip my 1. I times by 12. I skip my 1. I times by 2.54. I skipped my 1. I times by 1,000, and then I divide by 100. I hit equals at the final time, and I have my raw answer. Now, my raw answer, 19312. 121. And then there's more, but I don't care about that because I know I'm not going to need that many digits. This is my raw. I look back at what I've got on from my known. This is not significant, it's just a placeholder. So it don't matter. This is significant and that is significant, which means I only have 2 sig digs for my start. And since I've only got 2 sig digs, that means I only need to go 1, 2. Does the 3 round up to 9? Nope. Which means my final answer is 1, 9. Then placeholder, 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 placeholder. 1, 2, 3, 4 zeros. All not significant placeholders, but still important. And then if I check my units, we can see miles canceled, feet canceled, inches canceled, centimeters canceled, and millimeters are left, which is what I wanted anyway. So there I go. Do you see that? Now, let's say we did this slightly differently. Let's say we did this still doing the 0.12 miles. But instead of going to feet, I went to kilometers. 1 mile is equal to, and I'm going to double check this just in case. I do not want to be wrong. 1.61 kilometers. Now, I don't want kilometers. I want millimeters. So I bring this down. Kilometers goes down. I'm going to change that to meters. There is 1,000 meters in 1 kilometer or kilometer. But I don't want meters. I want millimeters. So for every 1 meter, there is 1,000 millimeters. And as you see there, I'm done. That's it. All right. And now I'm going to go get my raw answer. So before, where I needed 5 steps, this second time I only needed 3. So let's plug this in. 0.12. I put the 0, didn't need to, but it did it anyway. All right, times 1.61 divided by, well, we ignore because it's just a 1, times 1,000 times 1,000 equals. And again, we are going to get a raw number of 1,932,000. Class, do we have any confirmation on that? Did you plug it in, get the same? I see Kenna nodding. I'm sorry about that, Alexis. I see Alexis nodding. All right, so we all good? Got my 2 confirmations? Fantastic. Now again, I started with 2 sig digs. I'm going to end with 2. The 3 does not kick up the 9. And as you can see, then I've got 1, 9, placeholder, 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 placeholder. Wait, 1, 9, placeholder, 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 placeholder. I get the exact same answer. Because those are the only 2 numbers that were important. Now, if I sit there and check, I still see miles cancels, kilometers cancels, meters cancel, and I am indeed left with millimeters, which is great because that is my unit. This is how significant digits shows you what's important. In this thing, only 2 digits mattered. So at the end, only 2 digits mattered. Now, you can even see with how I had this here, if I had it be that we had 3 digits, let's say it was 0.120, that third 0 being significant, I'd now get 193 placeholder, placeholder, placeholder for both of them. Do you see that? But if I went even further, 0.1200, then I'd get to something interesting because I would wind up with 193,200, 193,100 with the placeholders. And you know what's funny? Both of those would be right if you had the work to back it up. Got it? Now, pro tip. The least number of conversions, the better. If you can do it in 1, if you can do it in 2, better. Metric conversions are considered lossless, meaning there is no hidden rounding, so they are better. The least amount of times you go between, where do we have? Metric and imperial, the better. So if you're doing something where you're going metric, imperial, metric, imperial, metric, imperial, your number is going to be way worse than if you just moved once and stuck with it. All right? Yes, sir.
Does the larger unit have to be on or the smaller unit have to be on top?
Does a smaller unit? No, we just happen to go from big to little. As I did in the last one, I thought I went the other way. I went from little to big. I might not have. No, I think I still went from big to little. That's my bad. I meant to switch it. If you go from little to big, this would be flipped. Like, let's say I went from millimeters over to miles, then all these things would be flipped over. I'll have to do that for an example as well. In fact, why not? Let's do that as an example. Do you have any questions on this before I erase it? Okay, so I am now going to do just that. I'm going to erase everything. All right, so we're going to do an example, or we're going to do a practice together. And for those of you who are going to be watching this video later, I challenge you to do this practice. Pause the video, or Maybe I'll just have there be a time and go from there. Okay, so I'm getting my board all set up, all erased out. All right. So we went from big to little, big to little. Let's flip this the other way. Let's go from little to big. All right. So let me pick a unit that's little. Oh, we'll do milliliters. Okay. If I have 4200 dot milliliters, and I want to know, I messed up the colors. That's going to annoy me later, but I'll just deal with it now. I want to go from milliliter. Let's see. Oh, we'll go to cup. Milliliter and cup. Yep. Okay, good. Okay, now, if I'm going to go from milliliter to cup, I'm going to take a look at my conversions paper. Now, this page is already on Schoology. This is already on the agenda for today. I highly recommend you either bookmark it, download it, whatever. Now, I'm going to be upgrading this later today, so you may want to wait till this afternoon before you actually download the thing, but you can still look on it, and it shall be improved later. There's 2 tweaks I want to make to it. Now, so if I have milliliter and cup, as I look here on my paper, I've got milliliter to fluid ounce as my first equality, where it is 29.41 milliliters is equal to 1 fluid ounce. And there should be 8 fluid ounces per cup, but I'm going to double check it, and that is right. 8 fluid ounces is equal to 1 cup. So this should be a 2-stepper. Go for it. See if you can figure it out. No problem. 29.41 milliliters is equal to 1 fluid ounce. And 8 fluid ounces is equal to 1 cup. Also, while you are working, I want to take this time to remind you, yes, I know there are other ways to do this. Yes, I know that you may even find those ways to be easier. That is not the point of this lesson. The point is to take these easy things to learn an important skill that you are going to need for more complicated questions later. Sorry, one sec. Chastity, go right ahead. Again, sorry, Josh.
Is that 4200 and then the point?
Yes, 4200 dot. And if you remember your significant digits, that dot is important. It is, in fact, significant. All right, I'm going to now start writing on here. If you're still working, that's good. I'm going to carry my known down of 4200 milliliters. I do not need to put my dot here. I just need to know it in the problem so that when I do significance, I'm set. I immediately times in line and I pull my milliliters down. Now, if I look at my equalities, my first equality there is 29.41 milliliters equals a fluid ounce. So I'm going to put that there. 29.41 milliliters is equal to 1 fluid ounce. Fluid ounce is not what I'm looking for, so I do another times line and I bring fluid ounces down and I change that to cups. Sorry, jumped the gun as far as my color coding. I'm going to change fluid ounces to cups. For every 1 cup, there's 8 fluid ounces. And yeah, that's all I need to do there. Now, if I sit there and I look at it this way, instead of multiplying over and over again, I'm actually going to be dividing over and over because I'm going from something that is very small something that is bigger. So in this case, I'm going to divide, but I don't even like to think of it that way. I like to think of the simple thing. If it's on the top, multiply. If it's on the bottom, divide. It's the beautiful thing about dimensional analysis. It tells you to multiply or divide as long as you do it proper. That's why that dropping it down right away is super important. If you can do that, you're golden. It's not going to be too bad. 4200 divided by 29.41. I ignore the 1. Then I hit divide again because the 8 is there. I ignore the 1. I hit equals. This gives me my raw number of 17.851. 17.851. And since I got more digits, I'm going to do 07. This here is my raw. I look over here. I've got only 2 sig. Oh no, I don't have 2 sig digs because of this dot here. That is telling me that I don't have 2 significant digits. Now that's telling me that the whole thing is significant. That is that trick. I believe it was trick 1. Our first trick with significance. That dot says the whole thing, all 4 digits are significant because of that dot. That is our clue. As such, when I sit there and I take this, I go to 4 digits. 1, 2, 3, 4 digits. The 1 does not kick up the 5, which means I'm at 17.85. When I go to units, milliliters cancel, fluid ounces cancel, and I'm left with cups, which is what I want. This is my final answer. Now, you may go, Mr. D, why did we not put zeros here? 1, 2, 3, shouldn't I put 3 more zeros? No, those zeros would be significant because they're after the decimal. So no, you don't put them. They do not serve any purpose other than to show significance. So we do not put them. In the previous problem, we had to put zeros as placeholders so that we kept our number at the right strength. In this case, any extra zeros would lie to my audience, telling them that that number was way more trustworthy than it should be. Do you understand that? All right, so Mr. Beck, a shout out. Thank you for sitting there and saying we need to go the other way because that helped us get a beautiful example question. You've now seen 3 dimensional analysis questions with significance. Rachel, question. Of course.
Sorry.
Yeah, I didn't know if you could see from here. No.
It's like it's the other way around. So
Oh, it's flipped. Yeah. I'm sorry.
Yeah, it's okay.
Okay. So can you see now?
Yeah.
Yeah. Yes, Katie, you may. All right. Do we have any questions on dimensional analysis? You've seen 1 step. You've seen multi-step. In this case, it was a 2-step. Earlier, you saw something that could be a 5 to 3 step. And that's the thing, is after you get past 1 step, it's all the same. You just keep going. Now you may go, Mr. D, what is the longest one you've ever done? The longest one I've ever done was a 17-stepper, and it was a challenge between me and a bunch of college students to see how long we could make one. All right, so we made a 17-stepper. The longest practical one I did is in order to plan a vacation, I actually did a complicated word problem dimensional analysis to figure out how much money I would need to spend on gas for a trip down to North Carolina. Well, I did it. It was 7 steps with a bunch of conversions, and I was off by a dime because I miscalculated Maryland state taxes. Now, I was pretty impressed. That was a big nerd moment there. I was pretty happy about that. So there we go. That's dimensional analysis. All good? Okay. So there we go. We are set. Oh, my thing to stop the recording isn't here. Did you close without me giving you permission? Okay, I'm going to go figure out this technical issue. If you take a look over at your weekly agenda, On this one here. Oh, there we go.